Trigonometric Identities and Equations, Pure 2, Chapter 6. Wonderful resource by Dr. Frost, slightly adapted by myself. So in this chapter, we're going to be looking at exact trig values and the unit circle and introducing the cast diagram. We're going to be using identities, sine over cos equals tan, sine squared plus cos squared equals 1. We're going to be solving trig equations, and we're also going to be solving them in quadratic form. So it's really exciting. So the unit circle. Here we have the unit circle, and from the unit circle, if we just look at the values of theta in the range of 0 to 90, we know that sine theta and cos theta are the lengths on a right-angled triangle, and that is because we know, if we go back to SOHCAHTOA, we know that sine of x equals opposite over hypotenuse. Now, in this case, if we're using the unit circle, our hypotenuse is 1. So our sine of x equals our opposite, because opposite over 1 is just opposite. So here we have sine of x. And then our cos of x is adjacent over hypotenuse. When our hypotenuse is 1, that means our cos of x equals our adjacent. Now, what would be the gradient of the bold line? Now, if we think about gradient, we're doing difference in y divided by difference in x. So our difference in y is sine x over cos x. So I don't know why I've put a here. I think it's because I was thinking of adjacent. And sine x over cos x. This is our gradient. What we also know, though, is actually our sine is our opposite and our cos is our adjacent. So this is the same as our opposite over adjacent. Now, opposite over adjacent is, in fact, tan. So this is where we lead to the first identity, that tan equals opposite over adjacent, which is also sine x over cos x. So tan of x equals sine x over cos x. So it's really good that we can use this right angle triangle between 0 is less than theta is less than 90 to work this out. And the unit circle can help us with this. What we can do, though, is use the unit circle to actually help us in creating a cast diagram. And what we're going to be doing with our angles is measuring them anti-clockwise. So this is how we're going to start the cast diagram. So the cast diagram is a fantastic diagram that's used, and it uses the graph. So we know for sine, the sine graph looks like this. And we can see, we know this is 360 degrees, 270 degrees, 180 degrees, 90 degrees, 0, and our minimum is -1 and our maximum is 1. And then for the cos graph, cos cuts. So it cuts the sine graph, and we know this is a translation of the sine graph. 360 degrees, 270 degrees, 180 degrees, 90 degrees, and 0, maximum 1, minimum -1. And then we also have our tan graph as well, which we're going to come to in a second. So for these graphs, for sine and cos, and now we have the tan graph. Now the tan graph, forgive my drawing, it's not always the best. Here we have 90, 180, and then we have 360 degrees. Might just sort that out a little bit. So we've got our asymptotes as well at 270. And we have no maximum or minimum. So what we're going to do now is we're going to look at whether we have positive values of y. So if we look between 0 and 90, so if I was to just have a look between 0 and 90, and we know here this is 90 degrees. And if we imagine this is 0 and this is 90, and we're going this way round, okay? So between 0 and 90, all of our graphs, sine, cos, and tan, are positive. So we're going to call this A for all. If we move on between 90 and 180, because we know here on our degrees between 0 and 180, this is a straight line, and we know that angles on a straight line add to 180. And we also have another right angle here, essentially, so 2 right angles. Which do we have that's positive? The only graph that's positive is sine. All of the rest are negative. So this is sine is positive here. Now, if you imagine we're then going to 270, if I add another 90 degrees, if I'm looking at this angle here, between 180 and 270, the only positive graph is tan. And then lastly, if I was to make a full circle and go back to 360, if I have a look at where's positive between 270 and 360, it is cos. So here you can see the CAST diagram, C-A-S-T. And A stands for where they're all positive, all the graphs, between 0 and 90 degrees, all of them have positive y values. Then between 90 and 180 degrees, it's only sine. Then between 180 and 270 degrees, it's tan. And then between 270 and 360 degrees, it's only cos. So this CAST diagram is going to help us to find angles, because even though we can use symmetry, for example, we know if 30 degrees is a half. So if I was to go across, I'd get 30 degrees, and if I was to carry on going, using symmetry, I know that this angle must be 30 degrees. So this is 150 degrees. And it's nice and easy. So we know sine of a half equals 30 degrees and 150 degrees. And it would keep going if we went over the interval between 0 is less than or equal to x is less than or equal to 360. So this is nice and easy, but when we have a transformation, this is when it gets a bit more difficult, and this is where the CAST diagram can help us. So we're going to understand how to use the CAST diagram on the next slide. So very quickly, a mini exercise. Have a look at your values and the gradient and see if you can understand what's going on. So between 0 is less than theta is less than 90 degrees, we know that cos is positive, sine is positive, and tan is positive. When theta is 90 degrees, if I was to draw that, so we have our x and our y, say 90 degrees. This is my 90 degree angle, so here's my angle. There's my theta. What do we know? We know that cos is 0. Our sine value is 1. And our tan is undefined, because we know that's where the asymptote is, because it doesn't have a gradient. Between 90 is less than or equal to theta and less than or equal to 180. We're having a look at this the angle is going to be roughly around here. It's going to be in between 90 and 180 degrees. Now, in this section, we know that our cos is negative and our sine is positive and our tan is negative. Moving on, when theta is 180 degrees, we know it's going to come here because this is 180 degrees. And our cos is at -1, sine is 0, and our tan is 0. Between 180 and 270 is about here. We know our angle is here. It's in between 180 and 270 degrees. We're going to have negative gradient, a negative gradient, and a positive. Sorry, not gradient, negative values. And that would lead to our tan being positive. Then theta equals 270. We know this is going to give me this angle here all the way round to 270 degrees. Now we know our cos is going to be 0, sine is 1, and again our tan is going to be undefined. So if you think about it as well, our tan is sine 1 divided by 0, which is going to give us undefined. And then between 270 and 360, our angle is going to be roughly in this quadrant. Here we go. We know this angle is going to be roughly between 270 and 360. And we're going to have a positive value of cos, a negative value of sine, and a negative value of tan. And again, here, it's drawn slightly better if you need it. So, the unit circle explains the behaviour of the trig graphs beyond 90 degrees, and that's why we use them. So what we're going to do is we're going to have a go at a few questions. Now, using the cast diagram, there are also some angle laws that we could use, but today we're going to focus on the cast diagram. So these are just a few trig angle laws which we spoke about the symmetry. And when we were doing our GCSE, we've already seen this because this is what we had to do in our trig objective. And we've had a look at the symmetry. And we know that sine and cos repeat every 360. And we know that that cos is a transformation of sine. This is all well and good, but how could we apply the cast diagram to what we know? So without using a calculator, we are going to do that for the next set of questions. Okay, so to start with, we've got tan of 225. So if I was to draw my cast diagram, tan of 225, if I think about where 225 is, I know if this is 0, 90, 180, 270, it's got to be in between here. So roughly 225. I know I'm going to reflect it here. So now I can think 180 plus what was 225? That was 45. So that means this angle is 45 degrees. Now we all know what tan of 45 degrees is, and that is 1. So tan of 225 is the same as tan of 45, which is in fact 1. Tan of 210, again, if I was to change this now to 210, (180) plus what's 210? It's 30 degrees. So that means this angle is 30 degrees. So tan of 210 is the same as tan of 30 degrees, which is in fact 1 over root 3. So this is my tan. Okay, if I have a look at my sine now, I have sine of 150. 150 is roughly here. And if I think, how did I get 180 take away what's 150? 30 degrees. So that means this angle is also 30 degrees. With sine, we always reflect it in this vertical line. With tan, we carry on the diagonal, and with cos, we reflect it in the horizontal line, because if we think about our diagram, C-A-S-T, we're looking for where it's positive. So sine of 150 is the same as sine of 30. I don't know why I've put tan, sorry. Sine of 30, which we all know is a half. Now I'm going to have cos. Cos of 300. 300 degrees is roughly here. If I go from 0 all the way round, it's going to give me 300 degrees. And with cos, I'm going to reflect this in my horizontal line. So 360 to what is going to give me 300? And that is 60 degrees. So I know that's 60 degrees, so we're going to have cos of 60, which we know is a half. Now sine of minus 45. If I was to draw minus 45, here it is, 45. Again, I'm going to reflect this in the vertical line, 45 degrees. Sine of negative 45 is the same as 0 all the way around 180, 225, which doesn't help us actually, but it's just good for us to do. But I do know what sine of 45 is. So that's actually the same as minus sine of 45, which is minus 1 over root 2. Cos of 750. Now if I think about this, if this is 0, and I go around 90, 180, 270, 360, I can keep going. 450, 540, 630, 720. I'm now at 720 degrees. So 750 would mean my angle would now be here, and this would be 30 degrees. I would still reflect it here, and now I could start at 0. So actually cos of 750 is the same as cos of 30 degrees, which is root 3 over 2. And then lastly with cos, I've got cos of 120 degrees. If I go from 0 all the way round, this is about 120. This would mean this is 60 degrees. Again, I reflect it in the horizontal line, 60 degrees. So this is the same as 120. Go all the way round. So I'm going to have 120 degrees, or this is going to give me cos of 240 degrees. Again, nothing's really helping me right now. But cos of 120, as you can see, normally we have our cos here, so this would mean we could also flip it and do the negative. This is negative cos of 60 degrees, which equals negative a half. Okay, test your understanding, give these questions a go. It says without a calculator, but just use the CAS diagram and see what other answers you can get, and you can use your calculator if you feel the need. Okay, so here are the answers. Is this what you got? I hope it is, and that we're ready to move on. Okay, so trigonometric identities. So returning to our unit circle. When our hypotenuse is 1, okay, our sine is our opposite over hypotenuse, isn't it? Okay, so this gave us the sine. Then as we were doing our spaghetti, okay, you remember we got the spaghetti, did our unit circle, and then we measured all the angles, and then our sine would be this one, because we started 0, and then when we got to 1, go up to 90, and then we remember we came back down, and went across. And this side is our cos. Now, using our trigonometric identities. So, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. What is my tan? Yeah. Tan is opposite, which this is our opposite the angle, over our adjacent. So tan is sine over cos. Or as I like to say, silly cow. Okay? Silly cow. SC, silly cow. So our tan is sine over cos. This is the first identity. Now this will hold true. For example, tan of 50 is sine of 50 divided by cos of 50. This will hold true. This is an identity. Now, we have a right angled triangle. Who's our favourite man? Pythagoras, absolutely. Okay? And Pythagoras says that a squared plus b squared equals c squared. So we're going to come on to our second identity. So, it doesn't matter which way you do it, but sine squared theta plus cos squared theta equals 1 squared. Now I'm actually going to just rewrite this. I skipped the gun. Okay, it's cos bracket bracket squared squared brackets. Okay, remember to put your brackets in, yeah? But sine theta squared can be written as sine squared theta plus cos squared theta equals 1 squared, which is 1. So there is our second identity. Now I can't remember if you need to know these because I don't have a formula sheet on me. But what you find is that you learn them, okay? So what we do with these identities is we try and prove other identities. For example, it says prove that 1 minus tan theta sine theta cos theta equals cos squared theta. Okay? You have to prove this. Now, the only way to prove this is to use what you know. The two things you know, you should put in a magical box. Okay? Silly cow and sine squared plus cos squared equals 1. Now, you can manipulate these. For example, tan x equals sine over cos. Well, you could also say that tan x multiplied by cos x equals sine x, couldn't you? Because all I've done is multiply my tan and my cos here. Okay, this is just manipulation. So if I multiply both sides by cos, the same with speed equals distance over time. Time multiplied by speed equals distance. You know, I can manipulate this however I want, it's still the same. As long as we manipulate it correctly, obviously. So how do we prove this? Normally, we start on the most complicated side. Okay? And we write down, are we going to do the left-hand side or the right-hand side? Left. So I'm going to write LHS. This is an abbreviation. And what does it stand for? Yeah, left-hand side, you know? Like other abbreviations that you know. So, left-hand side equals 1 minus tan theta sine theta cos theta. Okay? Now, you can manipulate, do whatever you want. We could probably do this question in a few different ways. Some of us are going to get us to the right-hand side quicker than others. Okay? Now, it is ingrained in my brain that if I see a tan, I immediately think silly cow. Okay? So, instead of writing tan, what am I going to substitute in? Yeah, so this equals 1 minus bracket. Now, whenever I substitute, I write a bracket. Sine theta over cos theta. Now, remember, with proof, multiplied by sine theta, cos theta. With proof, we have to show every step. That's the whole point. We're proving it step by step. So, this equals 1 minus sine theta times sine theta times cos theta over cos theta, doesn't it? Now, immediately, we have a factor of cos theta on the numerator and the denominator. They can cancel out. And this equals 1 minus sine squared theta, because sine theta times sine theta is sine squared theta, yeah? 5 times 5 is 5 squared. Okay, now, as I said, we could manipulate. Now, we know that sine squared x plus cos squared x equals 1. So if I minus sine squared from both sides, I get cos squared x equals 1 minus sine squared x, do I not? Here I have 1 minus sine squared theta. So this, instead of writing 1 minus sine squared theta, I could in fact write cos squared theta, which equals the right-hand side. Therefore, proved. So 1 minus sine squared theta is, in fact, cos squared theta. Using this rule, I know that sine squared plus cos squared equals 1. This is the same as cos squared equals 1 minus sine squared. So instead of writing 1 minus sine squared, I'm going to write cos squared. Okay, here are more examples. If you want to go ahead and do them, you can without me, and then I will... I'll do these in a second. Step 1, write down the 2 rules. Okay. Tan is silly cow. Tan theta equals sine theta over cos theta. And we know our favourite man is Pythagoras. Sine squared theta plus cos squared theta equals 1. Sorry for the crumpling on the video. So, I see a tan theta. What am I going to write? Silly cow. But before I do any of this, we forgot. It says prove. If it says prove, what do I write? Left-hand side. The only reason I'm writing the left-hand side, it looks more complicated, yeah? Left-hand side equals tan theta plus 1 over tan theta. Now, tan theta is sine theta over cos theta. 1 over tan theta is 1 over sine theta over cos theta, which is in fact, so I'm going to get sine theta over cos theta plus cos theta over sine theta, because we know that 1 over sine over cos is cos over sine. Okay? Then, when I add fractions, I need to make sure they have the same denominator, don't I? Yeah? So I'm going to multiply this whole side by sine, multiply this whole side by cos. Or you could cross multiply, I don't mind. If I multiply this side by sine over sine, remember, because whatever I do to the denominator, I have to do to the numerator. And I'm going to multiply, sorry, wrong way round. I'm going to multiply this side by cos theta and this side by sine. Because remember, cos over cos is essentially multiplying it by 1, so we're not changing the actual value. Because anything multiplied by 1 is still the value. It's really important that we understand that. So, I'm going to have sine theta times sine theta is sine squared theta. Sine theta times cos theta is sine theta cos theta. Plus, cos theta times cos theta is cos squared theta over sine theta cos theta. Do they now have the same denominator? Absolutely. So I'm going to have sine squared theta plus cos squared theta over sine theta cos theta. Now, can somebody tell me what is sine squared plus cos squared? 1. So this is actually 1 over sine theta cos theta, which is the right-hand side, therefore proved. Okay? Now, I need to make something clear to you. When we are proving, you should write this. If you write these at the top of the question, make sure you write the word using. And you have those two identities there. So when you do this question, I would suggest you would write it before you write the left-hand side, using, and you've got the formulas there, yeah? So that when you go through it, they know where your substitution, okay? Now, the next one, sometimes might catch you out, but it's really easy, okay? You know that sine squared plus cos squared equals 1. If you see a sine squared, you want to try and manipulate this. We've got 5 though, which is a bit annoying. But both of them are a factor of 5. So step 1, I can take out a factor of 5 from both to get 1 minus sine squared theta. Now how could I get 1 minus sine squared theta? Well, using that formula, I know that sine squared theta plus cos squared theta equals 1. And cos squared theta equals 1 minus sine squared theta. Okay? Now, if I have to rearrange a formula to then help with our simplification, you should write that down too. Then you could put, therefore, equals 5 lots of cos squared theta. Because we know that 1 minus sine squared theta is cos squared theta. Yeah? Okay, test your understanding. They look complicated, it's really not. Break it down, discuss with someone, off you go. So, remember, we should always start with using tan theta equals sine theta over cos theta and sine squared theta plus cos squared theta equals 1. If you have to rearrange them, you have to write it down. We always have to start with this. Left-hand side equals, and we should write the equation again. Tan x cos x over the square root of 1 minus cos squared x. Then, now we can start substituting. We know that tan is silly cow. Sin x over cos x multiplied by cos x over the square root. We know that 1 minus cos squared is sine squared x, which then equals, we know that the cos's are going to cancel. So we're going to have sine x over sine x, which equals 1, which equals the right-hand side. Therefore, proved. So just quickly, sine x cos x, if I multiply that out, it's going to be over cos x. And then we can cancel them because we have a common factor on the numerator and denominator. So, step 1, make sure you are writing. Use it. Tan theta equals sine theta over cos theta. And sine squared plus cos squared equals 1. Then it's really important to write left-hand side equals cos to the power of 4 theta minus sine to the power of 4 theta over cos squared theta. Okay, so what we notice here is really simple, actually. We have a difference of 2 squares on our numerator. So we're going to write this as cos squared theta minus sine squared theta cos squared theta plus sine squared theta. All of this is going to be over cos squared theta. What else do we know? We know that sine squared plus cos squared equals uno. So this equals cos squared theta minus sine squared theta multiplied all by 1 over cos squared theta. I'm then going to have cos squared theta minus sine squared theta all over cos squared theta. I can split my fraction up to have cos squared theta over cos squared theta minus sine squared theta over cos squared theta. We know that cos squared over cos squared is 1. Sine over cos, silly cow, is tan squared theta. And this equals the right-hand side. Therefore, proved. Okay, here is an easy one for you. Off you go. Maybe you want to start with the right-hand side this time. Okay? Now, you're okay to start with the right-hand side. You're okay to start with the left-hand side, but you always go with what you've got more to play with. Okay, step one, write your rules. Okay, using tan theta equals silly cow, sine theta over cos theta, and cos squared theta plus sine squared theta equals 1. Now, on this side, I'm actually going to do right-hand side equals first because I've got more to work with on the right-hand side. 1 over cos squared theta minus 1. Another thing to note is if you want tan squared theta, think about what do you need to get there. I know that tan squared theta can be made by doing sine squared theta over cos squared theta. Okay, using this rule. So think about trying to achieve this. Okay, so right-hand side. Now, this one's a bit of a sneaky one, okay? But what do I know? I know that the number 1 equals cos squared plus sine squared. So I'm going to write cos squared theta plus sine squared theta over cos squared theta. So I've substituted that in. Then I'm going to have minus 1. I'm now going to split my fraction. Cos squared theta over cos squared theta plus sine squared theta over cos squared theta minus 1. Cos over cos is 1. Plus sine squared over cos squared is tan squared minus 1. We know the 1 and the 1 are going to cancel. So it's just tan squared theta, which equals left-hand side, therefore, proved. So before we move on, last lesson we looked at the rules. Now we know they're not called rules, they're called trig identities, okay? And the first one is tan theta equals sine theta over cos theta, silly cow. And then our favourite man, Pythagoras, we worked out that sine squared theta plus cos squared theta equals 1. Given that cos theta equals minus 3 over 5 and theta is reflex. Okay, first of all, what is a reflex angle? Greater than 180, but less than 360. Okay, so we're all happy with what a reflex angle is. Brilliant. We need to know this later. Okay? And it says find the value of sine. Sine. Sorry, I don't know where sine came from. Find the value of sine. So, what? We have cos, we want sine. Which equation are we going to use? We don't want tan. Sine squared plus cos squared equals 1, but I'm going to rearrange this. So we know that sine squared theta plus cos squared theta equals 1. So sine squared theta equals 1 minus cos squared theta. And sine theta equals the square root of 1 minus cos squared theta. Okay? This is simple rearranging here. You don't need to remember what sine theta equals. You just always start, and we should be really confident rearranging. So we know how to find sine theta. So what we're going to do is we're going to substitute. So we now know then that sine theta equals the square root of 1 minus cos theta squared. So that's minus 3 over 5 squared. And that is because it tells us that cos theta is minus 3 over 5. And this is cos theta squared. Everyone happy with this substitution? Perfect. So this means that sine theta equals 1 minus 9 over 25. So the square root of 16 over 25. Can someone just check that on the calculator? I'm pretty sure I'm right. So sine theta equals plus or minus 4 over 5. Okay, now, this is where it's important. It says theta is reflex. So we know what sine theta equals. We have two though, don't we? We have plus or minus 4 over 5, okay? So, how do we know which one is going to give us a reflex angle? If I go back to the cast diagram, okay, C-A-S-T. When we have a positive value, okay, our sine is only going to be in between here and here. And this is 0 degrees all the way to 180 degrees. Is this going to give us a reflex angle? So we need the value when it's negative, don't we? Yeah, because sine is positive between 0 and 180. So, the final answer is, therefore, sine theta equals negative 4 over 5, because this will give us a reflex angle. And what I mean by that, does anybody want me to go into more detail with this explanation? No? Okay, so we're just going to do a little side note. Let's say I did sine theta equals, wait there, I'll do it in a different colour. Let's say sine theta equals 4 over 5. What does theta equal, everyone? Inverse sine of 4 over 5? $53.1 degrees. Okay, so we know that's here, roughly, isn't it? 53.1 degrees. Now we know with sine we reflect. So here's going to be our next one, which is going to be 180 minus 53, which is 126.9. Okay? Are any of these angles reflex? No. But if I was to take sine of theta equals negative 4 over 5, what's my answer, please? It's going to give me minus 53, which is down here. 53.1, and then we reflect, we do the opposite, so we know this is 53.1. Okay, so if I was to go round, if I start at 0 and go round, the first one I'm going to hit is 180 plus 53.1, which is 233.1. This is a reflex angle, and this is why if we were to take the positive, we're not going to get our first reflex. Our first reflex occurs when sine of theta equals negative 4 over 5. So that's why it's important that we really understand the cast diagram. Okay, part 2. It says, given that sine theta equals 2 over 5 and theta is obtuse. Okay, what does obtuse mean? More than 90 but less than 180, absolutely. Find the exact value of cos theta. So again, I have sine, I want cos. So I'm going to use the sine squared plus cos squared equals 1. I'm going to rearrange it. So I'm going to get cos theta equals the square root of 1 minus sine squared theta. So I'm going to have cos theta equals the square root of 1 minus 2 over 5 squared, 4 over 9. So cos theta equals 5 over 9. Root 5 over 3. Is that right? Have I gone completely wrong? No, sorry everyone. Oh, what a fool, I didn't square 5. Okay, wait there. 4 over 25. What's 1 minus 4 over 25? 21 over 25. So root 21 over 5, plus or minus. Okay? Now, how is this going to, which one is going to give me the obtuse? Now, when in doubt, draw it out. Okay? So, we could try. Let's do cos theta equals plus equals root 21 over 5. What does theta equal? Shift cos root 21 over 5. 23.6. Now if I was to draw my cast diagram, 23.6 is roughly here. I'm going to reflect it here. Okay, is this going to give me an obtuse angle? No, because obtuse is in this quadrant here, between 90 and 180. So I don't even need to work out the next angle. I just know then that theta equals, cos theta equals negative root 21 over 5. Okay, so now we're going to look at solving trigonometric equations, okay? So they're going to become really, really useful now. Now, it's really simple. We're just going to ease into it. So, for example, it says solve theta equals a half in this interval between 0 and 360. Now, we've already previously looked at this, so this is just a bit of a quick recap. So, sine theta equals a half. So, when sine theta equals a half, theta equals, so I'm going to do inverse sine of a half, and I'm going to get 30 degrees. Now remember, it wants it in between the interval of 0 and 360. So I'm going to draw my cast diagram. Okay, I know my first one is 30 degrees. It's positive, so I'm going to reflect it in, this is sine, so we're going to reflect it. We're going to have it in the other sine. Okay, and remember, this is 0, 90, 180, 270, and 360. So I start from 0, and I'm going to go all the way to 360 and see where it intersects. If I start at 0, my first intersection is at 30, which I've already got written down. Carry on, my second intersection is here. This is 180 minus 30, which is 150 degrees. Carry on going round until I get to 360. There's no more intersections. I stop, because that is where my interval is. So to solve sine theta equals a half in this interval gives me two solutions, and the two solutions are 30 and 150. So these trig laws here and these rules that Dr. Frost has used on this PowerPoint is definitely something you can do, and this is how I was taught. I was never taught using the cast diagram. I just learned using symmetry and these rules. But when we get to pure 3 and pure 4, it's a lot easier using the cast diagram. So forget about this. We're going to be using cast, okay? Just for the first bit, and then if you can figure out and you understand a different way, that's fine. But we're going to be using cast. It's going to help us when we get to some of the harder questions. Okay, the second one says solve tan theta equals 10. Between this interval of minus 180 theta is less than 180. Okay? Now, first of all, to solve anything, this says 5 tan theta equals 10. I want tan theta equals. So what am I going to do? Divide both sides by 5. It's really simple. So I'm going to get tan theta equals 10 over 5, which is 2. Now I need to find what theta equals. Now, when I inverse tan of 2, I'm going to get 63.4 degrees. Now, rule of thumb is 3 significant figures, okay? Sometimes 1 decimal place, but roughly, it will tell you in the question. If it doesn't, Just go with 3 significant figures. Now, when I draw my cast diagram, remember, this is 0, this is 90, this is 180, this is 270, this is 360. Okay, our first step is we just label our angle, and our angle here is 63.4, which is roughly here. This is 63.4 degrees, this angle. Now we know tan, it goes C-A-S-T. So we're going to reflect, well, it's not really a reflection. It is, but in the line y equals minus x. And this is our angle. And this angle is still the same size, 63.4. Okay? So step 1, we put our angle in, we do the correct reflection. Okay, so our cast diagram is now ready to use. Step 2, we look at the interval. Now the interval says between minus 180 and 180. Okay? So with the cast diagram, I'm just going to start doing the positive. So is everyone happy I could break this up? We could do between minus 180 is less than or equal to theta is less than or equal to 0. And I'm going to do 0 is less than or equal to theta is less than 180 degrees. Is everyone happy? I'm going to split these two up. Okay. So I'm going to show you how we're going to find, this one's the easiest, between 0 and 180. Between 0 and 180 is this whole section. Where does it intersect? It intersects here. So we know our first angle is 63.4. Are there any other intersections between 0 and 180? No. Okay, now normally, so if we go clockwise, 0, 90, 180, 270, we're going around positive. If we go anti-clockwise, we're going to go round. This is 0. This is minus 90. Okay? This is minus 180. This is minus 270. And this becomes minus 360. Sorry, not if we go clockwise. If we go anti-clockwise, it's positive. If we go clockwise, it's negative. Okay? So now, I want the interval between 0 minus 180 and 0. So where am I looking? Between 0, minus 90 and minus 180. Okay. I have found an intersection here. How do I find this number? This number is in fact minus 180 plus 63.4. Which is minus 116.6 degrees. And there are no other solutions. Solve sine theta equals negative a half in the interval. 0 is less than theta is less than 360. So for our interval, we know our cast diagram, CAST. We know 0, 90, 180, 270, 360. So this is, we're only going in this interval between 0 and 360. So we're just doing one whole loop, okay? So sine theta equals negative a half. So that means theta equals minus 30 degrees. Okay, so it's given us a negative 30 degrees. So step 1, draw this on the cast diagram. Negative 30 is going to be roughly here, isn't it? This is 30 degrees. Yeah? Now, normally, we reflect in this line if it's sine, isn't it? We're here, we reflect it over. So I'm still going to reflect in this line. And here is my 30 degrees. Okay, so it wants it in the interval. So now this is set up, I can start going round. I start at 0. Is there any intersections between 0 and 90? No. 90 and 100? No. Sorry, 180. 180 to 270. Yes, I found my first intersection. What is this value? This is 180 plus 30, which is 210 degrees. So there's my first intersection. Carry on going round. Found my second intersection. This is 360 minus 30, which is 330 degrees. Carry on going round. I stop when I get to 360. So I have three values for theta right now. But this is where we need to read the question properly. The question says it only wants it between 0 and 360. So therefore, the final answer, even though that minus 30, we used it to help us, it's not included in the final answer because it does not want any negative values of theta. It only wants theta between the interval of 0 and 360 degrees. So our final answer is 210 degrees and 330 degrees. Okay, so next up. Solve sine of theta equals root 3 cos theta in the interval theta is less than or equal to 0. No, it's not. It's greater than or equal to 0 and less than or equal to 360. Okay, so remember everyone, I want a number on one side and I want my trig functions on the other side, don't I? So from here, I'm going to have sine theta equals root 3 cos theta. The most practical thing to do is divide both sides by cos theta. So I'm going to have sine theta over cos theta equals root 3. Hold on a minute, what have we got? Silly cow. Yeah, tan. Because we know that tan theta equals sine theta over cos theta, so I'm going to substitute in and say tan theta equals root 3. Now I have one trig function. I can find my answer. So that means theta equals 60 degrees. Okay, step 1, set up the cast diagram. It wants it between 0 and 360. So if I do my 60 degrees, it's roughly here. Tan, C-A-S-T, so this is 60. Okay, set it up, done. Now I'm going to go round and see what's going on. So if I go from here to here, this is my first angle. This is 60 degrees, which we've already written down. If I carried on, if I start at 0 and go all the way, and this is the angle I want to find, it's 180 plus 60, which is 240 degrees. And then if I carry on all the way round, it doesn't intersect again, and I stop. I stop when I get to 360, because that is where my interval is in between. Right, test your understanding. Give it a go. Let's say 5 to 10 minutes. Okay, so solve 2 cos theta equals root 3. So that means that cos theta equals root 3 over 2. So inverse root 3 over 2 is going to give me theta equals 30 degrees. So when I draw my cast diagram, I'm going to have 30 degrees. I know this is 30 degrees. So if I go all the way round, 330. So there we go, there's my 2 solutions. And that's how quick you can do it. For the second one, I get root 3 sine theta equals cos theta. So root 3 sine theta equals cos theta. So that means root 3 equals cos theta over sine theta. Now this is not silly cow, this is cow silly. So this is 1 over tan. So root 3 equals 1 over tan theta. So that means tan theta equals 1 over 3. Okay? Or you could rearrange it the other way, but either way you should get this. So if you do shift tan, 1 over root 3, we're going to have theta equals 30 degrees. Now again, I'm going to draw my cast diagram. I know this is 30 degrees. We're going to reflect it here because it's positive. 30 is my first one. 180 plus 30 is 210. So there's my answers. And you can see how quick I'm doing this. And when I'm doing my cast diagram, I'm not writing 0, 90, 180 or anything like this. But as you can see, with me being so fast and rushing it, I haven't read the question properly because the question says between minus 180 and 80. So Let's start that again. 210 is not quite the answer, but that's okay. That's me going positive. Let's go negative, shall we? So if I go negative, this is 0, minus 90, minus 180, so minus 150. I'm now going to look at my values for theta, and the correct answers are between minus 180 and 80 is minus 150 degrees and 30 degrees. Those are your two solutions. So, even though we can do this fast, again, make sure you read the question just in case. Now we're going to look at these types of harder questions, and this is going to come really handy into why the CAS diagram is even more beneficial for us, okay? Because even though there are these tricks, it is a lot easier doing it this way. Now, the difference between this question and the other types of questions are the fact that this time, you can see here, we've normally just seen questions where we have cos of x or cos of theta. Here, we have cos of 3x or cos of 3 theta. Now, what does that actually mean, though, in terms of the graph? Okay, this is a graph transformation. So, if you think about the cos graph, it's been transformed. All of our x-coordinates have been divided by 3. So, normally our cos graph would look like, well, it definitely wouldn't look like that. Sorry, my pen jolted. It would look like that between 0 and 360. But if all of our values are divided by 3, we're actually going to get 3 lots of that between 0 and 360. So it's going to look like this. Okay? Between 0 and 360. So if we were using the rules and the symmetry, etc., and we were thinking, okay, so where does it cross at minus a half? Minus a half is roughly here. So we're going to go across. We're going to have 6 solutions. Now trying to figure out, that was, where does this cross at? This normally crosses at 90. Now this crosses at 30. Where does this normally cross at? This normally crosses at 270. Now it crosses at 90. Okay, where does this normally cross at? So instead of doing all of this, you can see it's going to take a while, isn't it, to do all of that? We're not going to do that. What we're going to do is use our CAS diagram, and this is why our CAS diagram comes in handy, okay? Because no matter for what transformation, now sometimes we might have 3x plus 10, okay? So it doesn't matter what transformation, the CAS diagram can help us do it. So this is how we do these types of questions. Step 1. Cos of 3x equals negative a half. So what are we going to do? We are going to do inverse cos.
Good morning.
Hi, Miss. How are you? Of course, Miss.
Of course we are.
Your hair looks lovely, by the way. Really like it. Okay, so that means 3x equals inverse cos of negative a half. Just like we normally do, just the normal step, and we get 120 degrees. Okay. Now, a lot of people right now automatically want to divide by 3, don't they? We're not going to do that. Okay? We're not going to do that yet. So we have 3x equals 120 degrees. Okay? Our interval is between 0 is less than 3x is less than 360. But we no longer have x. What do we have? 3x. So we're going to change it. How do I change this x into a 3x? Multiply by 3. Whatever I do to this, I have to do to the whole expression. So x has been multiplied by 3, so 0 times 3 is 0. X times 3 is 3x. 360 times 3, 1,040? Is it? Pardon? 1,080. Okay, so That is the crucial step before we divide, because what happens, some people divide here, okay, and in a minute I will show you what will happen if we divide. I'm just going to show you the right way, and then I'm going to show you what would happen the wrong way, okay? So now we know that 0 is less than 3x is less than 1080. So when I draw my CAS diagram, so I start my CAS diagram. Okay, 120, we know the angle is roughly this big, isn't it? Now remember with CAST, it's C-A-S-T. So then my other, I always reflect it in essentially the horizontal line. So this is 120 as well, okay? So this means that this is 60 and this is 60. So here we go, I've reflected it and everyone should be happy with these reflections. So now I have my starting point. Okay, so now think about this. I start at 0, because this is 0, isn't it? I'm going to do this in way. And I get to my first angle, which is 120, which I've already written down. So 3x equals 120. Okay, I carry on. I get to this angle, this is 180 plus 60, which is 240. I carry on. When I get to here, I'm now at 360, aren't I? I've gone round one whole circle, and we know how many degrees are in one circle. 360. So now I say that this is 360, and then I know I'll go up in increments of 90, so this is 450, 540, 630, and then I'm going to get to 720. So now I carry on going round. If I'm at 360, and I get to this point again, I've done 360 plus 120, which is 480, so that's my next one. And then I carry on. I have 540 plus 60, which is 600. And then I carry on and I reach 720. But remember, the end goal is 1080, isn't it? So I don't stop there. I keep going. Okay, and if I think about it, after 720, I have 810, 900, 990, 1080. Okay, so I fill in my next lot so I know I have to go round. But really, you know we've multiplied x by 3, so you know you have to go around the circle 3 times. Yeah? So let's go round again. I'm now at 720. I go round to here. 720 plus 120. 840. I keep going. 900 plus 60. 960. Keep going. I stop once I get to 1080 because that is our maximum. So done. I found all the possible values. But remember, this is what 3x gave me. I want to find what x gives me. So now I have all the values. Now I divide by 3. So I divide everything by 3. 120 divided by 3, 40. 240 divided by 3, 80. 480 divided by 3, 160. 600 divided by 3, 200. 840 divided by 3, 280. And 960 divided by 3, 320. Now you can see all of these values are in between 0 and 360, which is what our interval is. It makes sense because we drew the cos graph earlier, and if we think the transformation, okay, we knew it should cross 6 times. So this is my recommendation of how to do it. Now, the reason why I say we don't divide first, okay, and I'm going to do it here. Classic mistake. Are we ready for this classic mistake? Okay? This here is a classic mistake. So, they've done cos of 3x equals negative a half. They've got 3x equals 120, so that means x equals 40 degrees. Perfect. Now it says the interval between 0 and 360. Great. So they've gone, this is 40, I reflect here. Okay, let's go round. First one, 40, check, done it. All the way round. This is 360 minus 40. 320. Perfect. Then stop at 360 because that's what the interval says. Great, I've got 2 solutions. Perfect. Right, off I go. Now, as you can see, that is completely wrong, isn't it? Because remember, the CAS diagram is like a little trick. It's there to help you. But it only helps you if you understand what's going on. You need to realise that cos of 3x is a transformation. How does that transform the graph? That transforms the graph by dividing all of our x coordinates by 3. So therefore, we're going to have 3 graphs in our normal 0 to 360. So if we put a -1/2 here, we know our minimum point here is -1, -1. So we know between 0 and -1 lies a half. So we can easily see there would be 6 solutions. So this is where we need to make sure we're using our common sense. And this is where the CAS diagram can let you down if you don't fully understand the question. The CAS diagram is here to help us. Okay? The CAS diagram is here to help us. But you still need to understand what's going on. And you really need to understand trig. Okay, so I've got 2 more examples for you. So I'm going to show you these 2 examples. Step 1, solve sine of 2x plus 30 degrees equals 1/2. So step 1, what we're going to do is we're going to, once we know it's in the correct format, we are now going to inverse sine. We have sine of something equals a number. So now we can inverse sine. So I'm going to have 2x plus 30 equals the inverse of 1/√2, which is 45 degrees. Okay, stop. Once we've inversed sine, we stop. Why? Because now we need to change our interval. What have I done to x here? I've multiplied it by 2 and then I've added 30. So if I need to do that here, I need to do that to every single side. 0 multiplied by 2 is 0, plus 30 is 30. X multiplied by 2 is 2x, plus 30. Perfect. 360 multiplied by 2, 720. Plus 30, 750. This is our new interval. And when we're doing our cast, we're going to keep going round so that it fits in this interval. Okay? Now with our new interval, we do cast. So the angle we're working with is 45 degrees. Okay? We're using sine. So we know it's here. Now again, if you're not sure, please write the words cast, C-A-S-T. Okay, but the more you do it, the more you'll be able to understand. So, right, we have an imaginary line, which is 30 here. We know it's below. This is our starting point here, isn't it, 30? Yeah? Because our least value is 30. So I go round. 45 is my first one. Okay, the next, go round. Remember this angle is 45 degrees. This is 180 minus 45, which is 135 degrees. Okay, I keep going round. I hit 360. Do I stop? No. I'm just going to fill the rest in for now. So this is 450, this is 540, this is 630. This is 720, and then if this is my 30, this becomes 750, okay? Because remember, we're stopping at 750, aren't we? So I carry on going round. I'm now at 360. I go round. I hit my angle line. 360 plus 45, 405 degrees. Keep going. I hit it again. 540 minus 45, 495 degrees. I keep going round. I've hit 720, but I do not stop at 720. I keep going till I get to 750. Lucky for us, I stop at 750. We haven't intersected again. Okay? Okay? So here we have 2x plus 30. Now, step 1. take away 30 from everything. So I'm going to have 2x equals 15, 105, 375, 465. Because I've taken away 30 degrees from everything. Now what am I going to do? Divide by 2, absolutely. So I'm going to divide by 2. So my x equals 7.5 degrees. 52.5 degrees. $187.5 degrees. 232.5 degrees. And there is the final answer. Now, if you think about this sine graph here, all of our x coordinates have been divided by 2, and then we've shifted it to the left 30 degrees, okay? So we are roughly expecting around 4, we could maybe a bit more, because normally our sine graph looks like this, but what's happened to us is that we've halved it, so now it looks like that. Not only have we done that, we've now shifted it to the left 30 degrees. So it's going to look like that. Can you see? And 1 over root 2, it could be, we could have 4 solutions. So roughly we know we're on the right track. Okay, perfect. Okay, and then the next question. Okay, next up. Solve sine x equals 2 cos x. So I've got a sine and a cos. What am I thinking? Yeah, divide by cos. So sine x equals 2 cos x. Sine x over cos x equals 2. Sine over cos, tan x equals 2. Okay, so shift tan of 2 is 63.4 degrees. Okay, I'm going to do my cast. 63. Remember, this is my angle. Okay, now we're starting at 0. We finish at 300. Okay. So where is 300? We know this is 270. So 300 stops here, doesn't it? This is where we stop. At 300. So let's go round. 0, what do I get? 63.4. Keep going. Round. 180 plus 63.4. 243.4. Keep going. I stop at 300 degrees. Okay, remember we're stopping at 300. Why? Because this is our interval. Now, actually, in our case, this hasn't actually affected us, the 300, but I'm being dramatic about it because it may affect you in different questions, okay? So you have to just remember you've got all the information, you need to have it all down. Okay, this is a 7-mark exam question. You have all the skills needed to do this. 7 marks, 7 minutes, off you go. Let's see how many marks you would have got. So first of all, it says solve for 0 is less than or equal to x is less than 180. Cos of 3x minus 10 equals minus 0.4. Okay, we know it's a transformation. So I've got cos of 3x minus 10 equals negative 0.4. So 3x minus 10 equals, and in your calculator, you're going to do the inverse of negative 0.4. I get 113.57. I'm just going to do 113.6. Okay, you would have got 1 mark for that. Okay, the second mark. Now we figured that out. We need to change our interval, don't we? What have I done to x here? I've multiplied by 3, then took away 10. So what am I going to do here? Multiply by 3, then take away 10. 0 multiplied by 3, 0. Take away 10, minus 10. X multiplied by 3, 3x take away 10. Okay, I know I'm right because it gives me this, which is what I want. Is less than 180 multiplied by 3 is 540, take away 10, 530. Okay, check. I now have my new interval. I have my answer. I now need to set up my diagram. So, 130 degrees, if this is 0, we're going to be over here somewhere. Okay, this is 113 degrees, that angle. Now, this is cos, and with cos, we reflect it in this line here. So, that means this is 113.6. So, now we're ready. This is 0, and we're going to go all the way around. Now, remember, where are we starting from? Minus 10, so it's just good habit. This is minus 10 here. Now, luckily it doesn't intersect anything, so we don't have to worry, okay? But always just double check. You don't have to draw it like I did, but just double check. Okay, start at 0. My first angle is 113.6. Keep going. Second angle, what is this? 60 minus 113.6, which is 246.4. Okay, keep going. I'm now at 360. Do I stop? No. What's my next one after 360? 450, then 540. But wait a minute, it says stop at 530. So my new stop is here, 530. So I keep going around. 360, I get to here, stop. So 360 plus 113.6 is 473.6. Okay, I haven't stopped there though. What do I now? Now I keep going. Stop at 530, because that is the last part of our interval. So now what do I do? Add 10 to everything. 123.6, 256.4, 483.6. Now what do I do? Divide everything by 3. 41.2. 256.4 divided by 3. 85.5. And then 483.6 divided by 3. 161.2. Now, double check. It says give your answers to one decimal place, which we did. We showed our working. We did 7 marks. Quadratics with sine, cos, and tan. So, as you know, we can have hidden quadratics, and we can also have quadratics with our trig functions. So there's 2 methods. Method number 1 is where we can use substitution. So we can let y equal sine of x. We can then substitute this into our equation to get 5y squared plus 3y minus 2 equals 0. From there, I can factorise or solve this using my calculator. 5y minus 2 and y plus 1 equals 0. So y equals 2 over 5 and y equals negative 1. Therefore, using my substitution y equals sine x, I'm going to have sine of x equals 2 over 5 and sine of x equals negative 1. So now from there, I can use my cast diagram to find my degrees, and I'm going to do that in a second. The other method is factorise without substitution. You should be fairly happy that instead of, having this as a y, we can just write sine x. So we're going to have 5 sine squared x plus 3 sine x minus 2 equals 0. We can put this into brackets. 5 sine x minus 2 bracket, sine x plus 1 equals 0. And then from there, we know that sine x is going to equal 2 over 5, or sine x equals -1. And we're right back, we're back at the completely same answers. Okay, so now what we have to check is that 0 is less than or equal to x is less than or equal to 360 degrees. So what we can do now is we can use our cast diagram. So I have sine of x equals 2 over 5. So that would mean that x equals inverse sine 2 over 5, which is 23.6 degrees. 23.6 degrees. Now using my cast diagram, 23.6, this is sine, this is 23.6. So if I go round, I'm going to start at 0, my first angle is 23.6. I'm going to continue round, start at 0, this is 180 minus 23.6, which is 156.4 degrees. And then continue all the row round, and I'm going to stop because I've reached 360 degrees, and my interval is between 0 and 360. The next one I have is sine of x equals -1. So I'm going to inverse sine -1. Now we should all know this is -90 on our calculator. And this is where your calculator gives you the degrees which is closest to 0. And if you think about our sine graph here, -1 is going to give us our minimum point, which we know is at 270. But our calculator is going to give us the answer closest to 0, which in this case is -90. Now what we can do is we get x equals -90. We see this is not in our interval, but that's okay. So on our cast diagram, we draw our cast diagram, we draw our angle, -90. We're going to, here's our 90 degrees. We start from 0. We're going to go all the way round. There's no reflection. And we're going to hit it at 270. So this is 270 degrees. So then finally, our answer is x equals 23.6 degrees, 156.4 degrees, and 270 degrees. And as you can see here, I haven't included the -90 because it's not in our interval range, and I've also put this in ascending order. Okay, 2 more examples. People get caught up on this one. Solve tan squared theta equals 4. So we know that tan squared theta is actually tan theta all squared. This equals 4. It's just the way that we write it. So that means tan theta equals plus or minus the square root of 4, which we know tan theta equals plus or minus 2. So when tan theta equals 2, theta equals inverse tan of 2, which is 63.4 degrees. Now remember, this isn't our only solution. So when we have tan, we have 63.4 and 63.4. So I'm going to go round, start at 0, 63.4, and then I'm going to do 180 plus 63.4, which is 243.4 degrees. So I've done my first one. Now for my second angle, I have tan theta equals -2. So shift tan -2. My answer is -63.4. It's going to reflect this here. And here's my angle again. And then if I start at 0 and go all the way round, the first time I hit it is 180 minus 63.4. So my theta equals -63.4. 180 minus 63.4 is 116.6. And then if I was to carry on going all the way round, I would hit it again here, 360 minus 63.4, which is 296.6 degrees. So now I'm going to double check my interval. My interval is between 0 and 360, so now I'm going to write my final answer. So therefore, theta equals 63.4 degrees, because the negative is not going to be included, 116.6 degrees, 243.4 degrees, and 296.6 degrees. And there we should have 4 answers. Second question. Solve 2 cos squared x plus sine x equals 3 sine squared x. Now I have a sine x and a sine squared x and a cos squared x. So I've got more sines essentially. So what I'm going to do is I'm going to substitute in, remember our trig identities, that sine squared plus cos squared equals 1. Therefore, cos squared equals 1 minus sine squared. So I'm going to substitute that in to where cos squared is. So I'm going to have 2 lots of 1 minus sine squared x plus 9 sine x equals 3 sine squared x. What I'm now going to do is expand and simplify and move everything to have equals 0. So we have a quadratic. So I'm going to have 2 minus 2 sine squared x plus 9 sine x equals 3 sine squared x. And then I'm going to have 5 sine squared x minus 9 sine x minus 2 equals 0. I can now factorize this. So I'm going to have 5 sine x plus 1 and sine x minus 2 equals 0. So this means that sine of x equals negative 1 over 5 and sine of x equals 2. Now we know that sine of x can't equal 2 because we know our maximum value of sine x is 1. And if we have a look, we can see that on the graph. This is 1, negative 1. So we're going to reject this. And we're going to continue with sine x equals negative 1 over 5. So when I put this into my calculator now, shift sine negative 1 over 5, I get minus 11.5 degrees. X equals minus 11.5 degrees. So with my CAS diagram, minus 11.5 degrees is here. Remember, I'm going to reflect. When it's sine, I reflect in this vertical line. I can have here, so this is my angle, minus 11.5. Well, it's not minus 11.5, this is 11.5 is my angle. It's only negative if we go backwards. Now, let's have a look at the interval. The interval says minus 180 is less than or equal to x is less than or equal to 180. So actually, what I'm going to do is I'm going to do between 0 is less than or equal to x is less than or equal to 180. So if I start at 0 and go all the way round, I haven't hit anything. So there's no solutions in that interval. And I'm going to do minus 180 is less than or equal to 0 is less than, it's less than or equal to x is less than or equal to 0. So if I go backwards, so this is going to be negative 11.5. And then if I carry on, I'm going to have negative 180 plus 11.5, which is negative 168.5. So remember, I'm figuring out this angle here, which is 168.5. And then if I carry on, I'm going to stop. This is my negative 180. So I have a total of 2 angles. So x equals negative 11.5 or x equals negative 168.5. Okay, what I'd like you to do is test your understanding. This is a typical exam question and it's worth 6 marks. Now you can see they've been quite nice because they've said even if you couldn't show that the equation can be written in this form, they've given you so that you can solve this. Okay, so step 1. We can clearly see that we want a sine squared, and we know the identity involving sine squared and cos squared is that sine squared plus cos squared equals 1. So I'm going to substitute in 5 sine x equals 1 plus 2 lots of, and we know that cos squared equals 1 minus sine squared x. So we're going to have 5 sine x equals 1 plus 2 minus 2 sine squared x. If I rearrange this, I'm going to have 2 sine squared x plus 5 sine of x minus 3 equals 0. So therefore shown. So that's part A, nice and simple. Part B, it says solve for the interval between 0 is less than or equal to x is less than 360. So I'm going to factorise this. So we're going to have 2 sine x minus 1 sine x plus 3 equals 0. So sine of x equals a half. Sine of x equals negative 3. We're going to reject this because we know our maximum or minimum value of sine x is plus or minus 1. Sine of x equals a half. If we inverse half, we should know it equals 30 degrees, but if you didn't, you will come to learn this. And then again, if I was to do my CAS diagram, 30, 30. For sine, it's 180 minus. Now this is quite an easy question in terms of the angles, because if you know the sine diagram and the symmetry, you won't need to use CAS, and we can see that is the final answer. Nice and easy, 6 marks.